Hello guys, next example. We just solved this example, slope deflection. However, now I am introducing a new variable or new variables into the example. Before it was only that, and it was calculate the internal the reactions in order to build the shear moment diagram. By the way, check the comments in the previous example in the shear moment diagram, because there's my dyslexia was killing me there, and I switched a number and the results were slightly different. But check the comments that I put in the previous example. Now I am including this new part. The support A now is settling, also B is settling, and C is also settling. And we solved this problem previously using the force method. So now let's use it, the slope deflection, and see what happened with this thing. Important, now this is settling, so you have different settlements here. So this is the original structure, and this is A, and this is B, and this is C. I don't know, C, really weird, ABC, because this is 25 and this is 15, entirely out of scale. But it doesn't matter. Don't do what I said. Don't do what I do. Do what I said. Do a nice drawing. And now that was the original shape. However, this A is settling by 1/4 of an inch. B is settling by 1 inch, 1 full inch, and C is settling by 3/4 of an inch. So this is 3/4 of an inch. This is 1 inch, and this is 0.25 or 1/4 of an inch. Meaning you're gonna have this chart of the deflections. So the first thing that we have to do for this problem is calculate that. Calculate the fixed moments, and we showed this in the previous example. I think that I don't want to be repetitive and do it again. Plain and simple, go to the tables, find your case, which is this one, apply the equations, and find the values, and we did that in the previous example. Second, because this is ending in a pin here, this is continuous, but this is ending in a pin and this is ending in a roller, then we're going to use the modified equation. This was also explained in the previous video for this problem, at least for calculating in this problem. Now, what else? What we didn't have is this part. So the first thing, the first item that I want to do is calculating this value, because in the previous one we didn't have it. Now we have the psi value. That value, remember, that psi is the relative displacement of the 2 points divided by the length, and you have to put the sign, whatever the sign is, positive or negative, according to the convention that we're using. So if we're calculating the settlement or the psi for AB, it's going to be the difference between these two settlements, 1 inch minus 1/4 of an inch divided by the length, and the length is 25 feet, so divided by 25 feet. But we have to convert this into inches. Remember, we need to keep these units homogeneous, so I'm going to multiply by 12 inches in every feet, and this cancel out, and inches cancel out, and then we can calculate our psi AB, and our psi AB is 0.75 divided by 25 and divided by 12, and this is 0.00. Remember, this is an angle, this is a rotation, so it's unitless. Well, radians if you want unit. So now we have this thing here. Okay, perfect, nice. Now the other important thing is looking at the distance. First, the differential settlement. This is our psi. This is the differential settlement, or the relative displacement, let's call it like that, between A and B. This is what we just calculated in the numerator. This is the distance, L, remember, 25 feet, and this is 15 feet. And yes, I know this is out of a scale. Now the other thing is the sign. So we said anything that anything that happens counterclockwise like that, or if you want to see it in terms of a slope, this is a negative slope, so you need to put a negative sign here. This is one of the critical points for this problem. If you just do that correctly and apply your equations, I mean, what else? It's just plug and chug and solving a system of equations at the end. Now, let's calculate here the same thing for this one. Now, look what happened here. This is the support B, says 1 inch, whereas this support says 3/4 of an inch. So this one here, this is for AB, and now this one here is the relative settlement or the relative displacement between B and C. That's what it is. So that side BC is going to be equal to 1 minus 3/4 divided by 15 times 12. Remember, this is the unit conversion. So that side BC, which is the same, I call it BC just to differentiate. Let's say the side for this span and the side for this span. That's the way it's supposed to be called. 0.00139. Done. Now the sign. What about the sign? Well, if you want to see this as a positive slope, it's positive. And if you want to see that like this is doing this, because it was like that and now it fell, then it's also positive. And we have that. Now the other thing that I'm going to do here is something that I did. Some people like to do it, some people don't like to do it. I think for when you're working with the slope deflection and you are including settlements, it will be convenient, for saying the least, that you pre-calculate the term EI. The term EI is going to be repeating everywhere. And you can try to keep it like letters, like variables, but there's going to be a moment in time that it's going to be a mess. So yes, let's just calculate EI as 29,000 KSI, which is kip per inches square, multiplied by I, which is 2,500 inches square. But my result, inches to the fourth, I'm sorry, but my result here is going to be kip inches square, and I don't want the result in kip inches square, so I'm going to divide that by 12 square, so I can convert it in kip feet square. And the idea for that is because the moment is going to be in kip feet, and I'm going to introduce the length in feet then. So EI is going to be equal to 29,000 times 2,500 divided by 12 square, which is 144. So it's going to be 503,472.2 periodic kip feet square. Good. Now the next step is just going through the process. What is the process? Well, let's calculate. Moment AB is 0, moment CB is 0. Why? This is a pin, this is a roller, this is a pin, so they are gonna be 0 no matter what. So now, next step, moment BA and moment BC. So let's start with the moment BA. I already had the equation for moment BA. There, yes, let's just substitute the values. Moment BA, page 2 out of. Moment BA is gonna be equal to 3 times E I, but this I is 2 I's. Not only I, it's 2 I's. So I'm gonna put 3 times 2 times EI. But what is EI? EI I just calculated as this value. Okay, divided by L, and L is 25. Now you see that was kip feet square. Now divided by feet. Now I have kip feet, the units for moment, because the rest is just rotation, is radians. Multiplied by rotation at B. Rotation at B. I have a rotation at B. The rotation at B exists. Minus psi, the chord, the rotation of the chord AB, which is negative here. So minus 0.0025. I'm telling you guys, this is the key. This science here is this is where students mess up every single time. Well, not every single time, but let's say 90% of the errors are there. So give me new material. Don't mess with the same errors. So I can comment on those. I mean, I'm just joking. Don't give me any error. Do it correctly. Now plus this. What is this? Fixed moment BA negative 156.25 minus this moment. What is this moment? This moment is AB. AB is 156.25 divided by 2. That's basically it. So my moment BA, at least the equation for the moment BA, is going to be 120,833.3 rotation at B plus 67.71. There you go. Now, what is the next step? The next step is calculating moment BC. And moment BC is going to be the same equation, but now I'm just going to change A for C. So moment BC is going to be 3 times EI, but in this case I is I, so EI is going to be 503,472.2 divided by L, but L is 15. Remember, this is EI, and I'm going to put this here. This is 2EI. Okay. Times rotation at B minus the rotation, the rotation of the chord BC, but the rotation of the chord BC is this one here, 0.0039, and it's positive, but this is negative, so 0.00139 plus the fixed moment, but now it's fixed moment BC, 56.56. Where are you? 56.25 minus AB, which is going to be now CB, minus 56.25 divided by 2. Okay, that's basically it. And then MBC is equal to is equal to 100,694.4 rotation at B minus 55.6. This is when you combine everything here, and this is my second equation. Now once again, 3 unknowns, 2 equations. What is the equilibrium? The equilibrium is at joint B, so MBA plus MBC has to be equal to 0. Every time, every joint has to go to equilibrium. And then we have this. Perfect. Put it together. This plus this equals 0. So 128.33.3 plus 67.71, and this is MBA plus MBC equals 0. And so for your rotation, negative 5.462 times 10 to the negative 5 rotation at B plug this into here, get MBA, plug this into here, get MBC. And the moment at BC is negative 61.1, and the moment at BA is 61.1. That's basically the problem. Now what do you do after this? Shear moment diagram. I mean, I already have the moments here. I already told you what to do. I told you have to divide this into parts and finish the problem. So we did that in the previous example, the procedure. So if you want to know what are the values for the reactions, I'm going to give you the values for the reaction. The reaction in AY that I got is 39.94. Keep. The reaction in BY that I got, it was 53.49. Keep. And the reaction at Y, it was 26.57. Keep. Those are the values. Shear moment diagram. Well, this BA is going to be positive, meaning it has to bring it down. So the shear moment diagram is going to show this value here as positive on the top. And yeah, so you can solve this problem like that, and it's really easy. I'm not going to do it. I always say I'm not going to do it, and I ended doing it. But anyway, if you have this, and this is A, 39.94, B, 53.49, and C, 26.57, and you have the distributed load on top of that. Value 3, right? Yeah, 3 kip per foot. And this is 25 feet and 15. And you do your shear moment diagram. Shear diagram, as I said, this is going to be 39.94, and 39.94 minus 25 times 3. 75 minus 39.94, that's going to be 35.06. 35.06, straight line going up, minus 53.49, that's going to be 18.43 minus 15 times 3, so 45. 26.57. I told you most of the time this is going to be like that, a straight line, jump, straight line, jump, yes. And then the moment is going to be something like this. Remember, once again, this distance is going to be that value divided by the load. So this distance is 39.94 divided by 3. It's going to be 13.31, and this value here is going to be, even if I don't finish, I know the shape of the diagram, by the way. I can tell you, because if you look at the moment BA, remember this is A, B, C, and this is the moment BA. The moment BA is 51.1 positive, so that means that in this side I have to end at 51.51 positive, like that. So the moment diagram is going to be something like this, up to this point and coming up to here, and this should go up and closing 0, and then you can say your big yes right there. This value is 61 here where the moment is, and now we can fill the blanks. If you want to know how much is this value, it's going to be 39.94 times 13.31 divided by 2. This is going to be 265.8. I'm doing this live, guys. I don't have results. And if I subtract this area, if this is 25, this is going to be 11.69. So 11.69 11.69 times this value. I say this value before, 35.06. 35.06. Yeah, I think so. Yeah, 6 divided by 2. And then you get 61, correct? And then you add to 61, you add this value, and this distance is supposed to be 18.43. 18.43 divided by the load. So 18.43 divided by 3. This is going to be 6.143. And this is going to be 61 plus that area. 61, I'm sorry, plus 18.43 times 6.143 divided by 2, 117.6. And then just for saying, for saying the biggest, yes, this value is going to be 15 minus that, or it's going to be 26.57 divided by 3. Same thing. So this is going to be 8.856 times 26.57 divided by 2. It's going to be this, 17.6. Yes, yes. Okay, let me emphasize that in case that you didn't hear it. Yes. Okay, now if you compare these with the previous, where is the previous one? Previous one, we did this just some minutes ago. Now, look at the diagram. By the way, the diagram with the corrections, these are the corrections that I said before. But look at the shape of the diagram before, and look at the influence now of the settlement. It's the same shape, but now look at what happened. Because of the support settled, the moment redistributed. Look at the value of the moment here, 164. Now because the support settled, now it's 265. That's huge. Look at what happened with the settlement. Before I have negative 152, and you can say, oh, that is positive. Yes and no, because if I have this, and this is reinforced concrete, for example, that means that I already reinforced the top by this amount. But look what happened now. It's a positive. Did I take that into account before, or didn't I do that into account? I don't know. And this value was 25, now it's 117. So that's it. The settlements is a big problem. A lot of people don't pay too much attention to that. Okay, next example. I'm gonna do another example. More supports, fixed supports. I hope that you enjoyed also. Keep watching.